Good morning, everyone. We're going to tackle our lesson for today. First quarter lesson is evidence of plate movements, seafloor spreading theory. Seafloor spreading and magnetic reversal. The idea of continental drift circulated in scientific circles until World War II, when sounding gear called SONAR produced new evidence of what the seafloor looked like. The gear developed in the 1930s bounced sound waves off the seafloor to determine its depth and features. It happened that the command of one attack transport ship, the USS Cape Johnson, was given to Harry Hammond Hess, a geologist from Princeton University. Hess, then in his late 30s, wanted to continue his scientific investigations even while at war. So he left his ship's sounding gear all of the time, not just when approaching part of navigating a difficult landing. What he discovered was a big surprise. Ocean floor exploration continued, and by the 1950s, other researchers had found that a huge rift ran along the top of the mid-Atlantic ridge that enabled Hess to understand his ocean floor profiles in the Pacific. He discovered that the bottom of the sea was not as smooth as expected, but full of canyons, trenches, and volcanic sea mountains. He realized that the Earth's crust had been moving away on each side of oceanic ridges, down the Atlantic and Pacific Oceans, long and volcanically active. Harry Hess observed that the rate of formation of new seafloor at the mid-ocean ridge is not always as fast as the destruction of the old seafloor at the subduction zone. This explains why the Pacific Ocean is getting smaller and why the Atlantic Ocean is getting wider. If the subduction zone is faster than the seafloor spreading, the ocean shrinks. He published his theory in History of Ocean Basins 1962, and it came to be called seafloor spreading. In the early 1960s, dating of ocean core samples showed that the ocean floor was younger at the mid-Atlantic ridge but progressively older in either direction, confirming the reality of seafloor spreading. Evidence of plate movements, magnetic reversal. Magnetic reversal, further evidence came along by 1963 as geophysicists realized that Earth's magnetic field had reversed polarity many times, with each reversal lasting less than 200,000 years. Rocks of the same age in the seafloor crust would have taken on the magnetic polarity at the time that part of the crust formed. Sure enough, surveys of either side of the mid-Atlantic ridge showed a symmetrical pattern of alternating polarity stripes. Seafloor spreading was strengthened with the discovery of the magnetic rocks near the ridge following a pattern aside from the fact that the rocks near the ridge are younger than those farther from the ridge. Magnetic reversal happened many times in the past. The occurrence of the magnetic reversal can be explained through the magnetic patterns in the magnetic rocks. These magnetic patterns allow our scientists to understand the ages and rate of movement of the materials from the mid-oceanic ridge. The magnetic reversal, also called the magnetic flip of the Earth, happens when the North Pole is transformed into the South Pole and the South Pole becomes the North Pole. This event happens because of the changing direction of the flow of materials in the Earth's liquid outer core. Over the last 10 million years, there had been an average of 4 to 5 reversals per million years. New rocks are added to the ocean floor at the ridge with approximately equal amounts on both sides of the oceanic ridge. By the 1970s, geologists had agreed to use the term plate tectonics for what had become the core paradigm of their discipline. They use the term plates because they have found evidence that not just continents move, but pseudo-whole plates of the Earth's crust. A plate might include a continent, parts of a continent, and/or undersea portions of the crust. Alfred Wegener's idea of continental drift had been developed and refined together with the seafloor spreading of Harry Hess. And that's ends our lesson. Thank you for listening.